All right, so what we have here is section 1.1, graphs and graphing utilities. And what we're going to do is start with talking about the coordinate plane. So hopefully most of this is just kind of a refresher on things that you knew from the past already, and it's more of just a review than new information. So the first thing we're going to talk about is the term ordered pair. An ordered pair is a group of two numbers like that. It's a pair, so two, and they are ordered. So you can't flip-flop the order of them. You want to keep them in the order that you're given. And examples of this would be things like 3, 8. That's not going to be the same as 8, 3. Those are two different things, so those are not the same. Okay, another example might be 1, 2. Another example might be -5, 4, and they don't even have to all be whole numbers. It could be something like 3 halves and 7 thirds or something like that. You can have ordered pairs that are like that. The next thing is the x-axis. This is our horizontal axis. You can see it here, right here on this graph we have right there. This is your x-axis. It basically tells you how much you move left and right. You move along that x-axis. We can combine that with the y-axis, which is our vertical axis. And that's this axis right here, vertical axis, to tell us how much to move up and down. Up would be positive, down would be negative. Another term you need to know and be familiar with is the origin. And the origin is right here where the two axes meet, where the x-axis crosses the y-axis. And that's that right there. It is basically the middle or center of our graph there. And it has a ordered pair value of 0, 0. Okay. After that, we have x-intercept. So x-intercepts is going to be the value or values in some cases where our graph crosses the x-axis. Okay, so if we had some graph that looked like this, then we would say that this right there, that value like -3.5 is an x-intercept, and this value right here at +1.5 and this one at +6, those are all x-intercepts where it's crossing that axis. The next one is the y-intercept, and this is the value or values where the graph crosses the y-axis. Okay, in the graph that I drew here, we really only have that happening once, and it's right there where it crosses it, and it's at like maybe 1.3 or 1.4 or something like that. All right, but it's just going to be that value of where it crosses that. Lastly, we have quadrants. Let me get rid of this. Quadrants are a division of our plane, of the plane, our XY plane in this case, by the two axes. That's the X and Y axis. So if we look at this, we have this, and it's making a division here where we have this area here, this area here, this area here, this area here. We have these 4 different areas, and we can label them as quadrants because they have different properties, and it'll help us navigate around this. Up here to the upper right is where you start, and we label this as quadrant 1, and this has all positive x values in the ordered pair and all positive y values in any ordered pairs that put you there, because you're going entirely in the positive direction in the x direction and positive y in the y direction. So you have ordered pairs that are both positive terms. Continuing counterclockwise, we move over to quadrant 2, Okay, and quadrant 2 is going to have negative x values, that first value for your ordered pair, and positive y values, the second value of ordered pair, because you're moving over here on the side with these negative x values, but you're still moving up in the positive y direction. So you end up with negative and then positive. Continuing counterclockwise, we have quadrant 3 right there. And here you're going to have all negatives for both ordered pair values. You're all entirely in the negative x direction and all entirely in the negative y direction there. So you should have all negative values. So if you get an ordered pair with both negative values, you know you're in quadrant 3. If you get, continuing moving over, you get to quadrant 4, going counterclockwise still, because in mathematics, rotations that are counterclockwise are the positive direction. It's right-handedness. These ones are going to have positive y value or positive x values and negative y values like that, because you're back to going positive in the y direction, but you're still below the axis down here on the negative side of the y values. So those are your 4 quadrants. And I'm going to pause it here real quick to see if we have any questions. All right, so now moving down, we're going to try this with a few points, and I'm going to try and color coordinate it for you. So let's start with plotting the point A. So we have this point A here is the ordered pair negative 3, 2. I'll do that point in red. So what this is telling me is to go negative 3 in the x direction and then a positive 2 in the y direction. Just like that. That puts me into quadrant 2. And it puts me right there at that point. That is point A. For point B, I'll do it in orange. It's the point positive 3, positive 2. So I'll start at the origin, go to positive 3, and then go up to positive 2, just like that. And that puts me right there for point B. For point C, we can pick purple, I guess. And we're going to the point 4, 0. That means I'm going to go 4 on the x direction in the positive direction, but I'm not going to go anywhere on the y direction. And so I end up just being right there. So that's point C. And then next we have point D. I'll do that in blue. So it'll be blue. It's at negative 5, negative 1. So I have to go negative 5 that way and down negative 1 like that. And that puts me at that location. And that's point D. And then point E is going to be, let's do green. Point E is at 0, negative 3, so I go nowhere in the x direction and just drop straight down 3 in the y direction to go to that location. And so that's that point right there. That's point E. And then the final one is point F. I'll do that in, let's go with yellow, I guess. Yellow, and that is the origin. I'm going to go 0 in the x and 0 in the y and get right there at the origin. That is point F. And I'm going to do one more. I'm going to add on a point G. Point G will make point, let's do 2.5 and then maybe 4.8. So something like that. So it doesn't have to be all whole numbers. It can be part numbers like that. So I would come out to about 2.5 like that. And then I would go up to about 4.8. Now I'm not probably going to get 4.8 exactly, but it's close to 5, closer to 5 than it is to 4. So I'd end up with a point about right there. And that would be my point G. Okay, so we can put points in that way. They don't have to actually be right there on the axis. Okay, next part, we're starting about equations. So I'm going to do a real quick little pause here and see if we have. So let's move on to understanding equations, this next page here. Basically, you can think of an equation. I mean, it has the word equal in it, right? So equations, you're going to have equal signs in them. So an equation in two variables, right? An equation in two variables is a statement about a relationship between two values. Statements can either be true or false. Solutions are ordered pairs that satisfy the equation, an equation with two variables, that is. That is, plug in X and plug in Y, and the statement will simplify and be true. So let's try some of that right here. So determine whether the given point is a solution for the given equation. So all we're going to do here is simply plug these in. This value here will be the X value. So we have X is equal to 0. This value here will be the Y value. So we'll end up using X is equal to 0 and Y is equal to 0. And then we want to see if that actually solves our equation. We start with Y equals 4 minus X squared. And I'm simply going to plug in 0 for X and 0 for Y and see if it stays true. So I plug in 0, and then I plug in 0 over here squared. And when I do that, I end up with 0 equals 4. So that is not true. That's a false statement. And therefore, 0, 0 is not a solution of that equation. It doesn't work. Now, be careful when you're doing stuff like this, because you don't want to start doing like what you do a lot in regular algebra, which is swapping things from side to side, like add X squared to both sides or something like that. You don't want to do that. You only want to really work on each side individually. You don't want to do stuff to both sides. You usually want to try and limit yourself to working on one side. And an example of that would be something like if I started off and said 2 equals 3. And you'd say, oh, that's crazy. And I'd say, no, watch this. I'll make them equal. And I'll just, what you do to one side, you must also do to the other side. And 0 times 2 is 0, and 3 times 0 is 0. Hey, 0 equals 0. That is true. Therefore, my original statement of 2 equals 3 must be true. So you want to be very careful that you're not doing something like this, because 2 equals 3 is not true. You don't want to do that. That is bad form. So let's take a look here at the next one. I'll do this one for you, and then I'm going to have you do the one after that. So let's determine if 3 negative 5 is a solution to the equation 4 minus X squared. So we have the same equation, but this time X value is 3 and the Y value is negative 5. So I'll do this a little more quickly. I'm going to take Y equals 4 minus X squared. I'm going to plug in negative 5 for Y, and I'm going to plug in 3 where X is, just like that. And so I end up with negative 5 equals 4 minus 3 squared. 3 squared is a 9. And so I have 4 minus 9, which is a negative 5. And so I have a negative 5 on both sides. Those two sides then do equal each other. And therefore, yes, 3 negative 5 is a solution to that particular equation. May not be a solution to another one, but it is a solution to that one. All right, I'm going to go ahead and pause the video now. I want you to try figuring out number 3 and determine if the point negative 1, 1 is a solution to the equation y equals 4 minus x squared. Real quick. All right, so this last one is checking if the point negative 1, negative 1 solves it. So this negative 1 is x and that negative 1 is y. So we'll just plug them in. I'll do it right underneath here. Negative 1 for y, 4 minus negative 1 squared. Be very careful when you plug numbers in, especially negative numbers, that you should pretty much always put them with parentheses around them, because negative 1 squared is not the same thing as negative 1 squared like that. This one is negative 1 times, this one is the negative of, this one is the negative of 1 times 1. This one over here is negative 1 times negative 1 like that. And so this one on the right equals a positive 1. This one on the left equals a positive 1 that you then take the negative of. And so they don't equal. So be very careful when you're, especially when you're plugging in negative numbers and stuff's getting squared, that you do that. So this is a -1. This is a 4 minus -1 times -1 is what that one is. -1 times -1 is +1. And so this squares to being 4 minus 1. And this is -1 equals 4 minus 1, which is 3. They are not the same. And therefore, this is not a solution. Okay? So we'll pick up there in the next class.